Hi everyone, in this video I will be explaining how planner-based orchestration works in LangGraph. So I have developed a quick prototype type of web application where I will explain. First I will give a demo how this planner-based orchestration is working, and then I will walk you through the code, uh, how I have developed it. So the difference here is that in planner-based orchestration, there will be a planner node which will get access information about all the tools that are available to be executed, and then it will simply create a plan around which tool should be used in what order and what should be the input to that tool, instead of just providing access to all the tools and letting the LLM try to execute on its own, which is totally out of control. We cannot control the behavior. Here, if we just get the plan, we can put a lot of checks at various levels to see whether the plan is going in the right direction or it is not doing anything random. So for that reason, this approach is much better compared to just giving all the tools to LLM and letting it execute on its own. So here I will just give a demo how this thing is working. So this is a dummy question that I'm asking in this application. Once I ask this, so this is the plan that the LLM has generated. First is search, then is math tool, then is summarizer tool. Okay. So if you see, the output also was generated in that order. So these are the three tools I provided to LLM: search tool, math tool, and summarize. Summarizer is a dummy tool, but in search tool, I'm using DuckDuckGo search. And in math, I'm asking it to just try to provide output of all the arithmetic functions. And this is a synthesizer node, which will generate the final output. Okay, so let me walk you through the code, how this was developed and how it can work. And before that, maybe I can try to walk you through the diagram or the graph of the LangGraph agent that I've developed. So this is the diagram how this agent is developed. So first will be the planner node. Here the input from the user will come. So this is the input: summarize info about capital of Karnataka and calculate this. So this input will go to a planner node, and planner node will generate the plan. So it will tell two things. One is that what tool should be used and what should be the input of that tool, and in an order. Like first, we should be using search tool, and this should be the input of that tool. Then we should use math tool, and this should be the input. And then we should use summarizer tool, and this should be the input of that summarizer. And then finally the synthesizer. So this part is where the real orchestration happens. So this is a dummy node which will not do anything. It will simply connect to a conditional router, which will tell whether all the steps of the plan have been executed or not. If not, then it will say false, and then it will go to the executor node. Executor will simply go back to the assign worker node. Here, the conditional router will keep checking whether all the steps have been executed. When the output is true, that means all the steps are executed, then the synthesizer node will be called. So this is just dummy node, which will help us continuously route between executor node and uh, help us execute all the steps. So this is the real thing. Rest everything is rather straightforward. So now let's go to the code, how it is working. So I have tried to put together a sample web application, but mainly I will focus on the LangGraph side of it. Remaining is simple HTML and fast Flask-based application development, which is rather straightforward. So yeah, let me go through this. So here I have imported all the necessary libraries. Here I am trying to load the environment variables, and here also I'm using an LLM from Grok online API. And if you want to know how this can be used, or how we can use this, you can just let me know in the comment section, and I will try to create a separate video dedicated to this. But the reason I use this is that this API is free of cost, and for basic testing and development, it gives a decent token limit per minute, and we can for free, which we can use for our development and testing. So we don't have to use any paid APIs here. Okay. Now I will go to the tools. So as I told, I have created three tools. One is search tool, math tool, and summarizer tool. So search tool is simply taking the query, user query. So this is not the input coming from the user. This is the query that the planner agent generates. When once I go through this, you will get to know that this is the query that planner agent generates. And based on that, we are simply calling DuckDuckGo search run. It is free of cost. Although the results are not perfect, they become incorrect also sometimes. But for demonstration purpose, this is a good API to use. So I'm simply sending my query to this tool, and whatever output comes, I'm returning the output of that tool as a search tool. Okay. Next is math, where the expression again generated by the planner node. So here it will simply evaluate that expression. So we have told the LLM explicitly that uh, this tool will simply evaluate the expressions. So the expression should be in mathematical form. It should not be invalid string type of expressions. Otherwise, it will not work. So if it is a string type of expression, it will return an error, and then the output will not be generated. Summarizer, here I have not done anything. Simply I'm returning summary of this text, because this is just for demonstration purpose. We don't really need real output from here. So these are the three tools. Now the tool metadata, we have created a dictionary. As you see, each of the tool has a docstring. Okay. So this can function as a description of each tool. So we are creating dictionary where the description part, which is a docstring of search tool, will go here, math tool, then summarizer tool. So this will work as list of tools along with the description, which we can send to the planner agent. Then yeah, so this description, we are just simply converting this dictionary to a string JSON. Okay, we are doing json.dump as. Then all the tools, so this is the list of tools, like we are creating dictionary. So planner will generate this output, right? So whether we can this string, whether we have to use search or math or summarizer. So this dictionary will help us when this string is there in the planner node, output of the planner node, then this tool should be called. Okay, that's all. This is the purpose of this. Then we have the this we are using to define the uh, structure of output of the planner agent. So planner agent, it will generate a plan output, which will be a list of steps. Okay, steps will be a list of plan step, and each element in the list which will contain these three items. One will be the step ID. Step ID will tell us that in what order those steps should be executed. They will be start from either 0 or 1, but in an order. Okay, so that the next executor or a router node knows that in what order to execute those steps. Then the tool, the output should be either of these three. So we are providing a literal here. The tool name cannot be any other value apart from these three values. And input, what input should be sent to this tool. Okay, so this we will using this we will create a structured LLM with structured output, which I will explain. Yeah, here if you can see, so that the planner LLM we are using with structured output method from a LangChain, and we are passing this class planner output. So the output of this LLM, whenever we send a prompt, it will always be in this structure. Okay. Now we have to define the state of the LangGraph agent that we develop. So the state will contain question, which is the I think the user question. Then the steps. So steps will be list of dictionary, and dictionary will contain both strings. Okay. The key will also be a string and value will also be a string. And the current step index. So this step will tell us that whether when we are executing it, what is the current state, whether we are at second step or third step. Based on that only, the if you see here, based on that only assign worker, the conditional router from here will decide whether we should execute further or the execution is completed. So if this is equal to the length of steps, then the execution will stop and it will go to the synthesizer agent. Then step results. So here we are saving all the results in one common field, and it will be a list, and dictionary of the key will be a string, and out the value can be any. Here we are using a reducer operator dot add, which means that whenever we send an output to step results, instead of replacing the existing value, it will keep adding the values here. So executor will send all the outputs from each tool to this field, and then it will keep adding. So let's say we are calling three tools in an order. So output from all these three tools will be saved here. And the final answer is the answer which is generated by the synthesizer. It will be saved here. Okay. So now let's see how we have defined the nodes. So this is a planner node where the initial query will go. So if you see here, this is the question. Yeah, this is the question that will come from the user. So in the prompt, we are simply asking your smart planning agent, your task is to break down the question into steps. For each step, use one tool from the list below. So these are the descriptions we are providing. So these descriptions we have created here. Okay. So this is the description. We are just this is just a string JSON of that. Okay. So we are providing all the tools, and it will simply provide a list in this uh, structure, that it will provide a list which every element of this list will have step ID, tool, and input. Okay. Use the tool that best fits the subtask based on the tool descriptions. Okay. Now we will simply send this prompt as a system message, then human message, we are sending the question that is coming from the user. So this will be sent in the initial state. Okay. And as a output of this node, we are sending the steps. Okay. So yeah, this we are sending, which will be a list of dictionaries which has these elements, and the current step index. So basically current step index means that when the planner agent has completed, we have not started the execution of each tool, right? So index will start from 0. So that is what we're doing here. Okay, next is assign worker. As I told you, it is going to be a dummy node. It will not do anything at all. It will simply return none. And but this is required to create the conditional routers from that node. From planner, we cannot directly create the conditional routers. Then is the executor node. Executor node, it will simply take all the steps, and index, it will take when the first tool has to be executed, the index will be 0, which means from steps we will take the first step. Okay, but as and when we run it, if you see here that we are incrementing the index every time we are running this. So let me walk you through each step again. So it will check that if the length of steps is, if the index is greater than equal to length of steps, then it should return a blank, and it should not do anything. Okay. So yeah, this is just a safeguard, but it will never reach here, because the conditional router itself will check whether the length of steps has already like index has already exceeded the length of steps. Then it will not come to execute a node it in first go. Okay. So step is that step of the index. Let's say we are starting from 0. So it will take first step. If we have 1, then it will take second step, and so on. Tool name is that in that step what tool we defined it, so that tool name we will call. Okay, then input text. So in the step, what is the input coming from the planner node, that should go to this tool. Then step ID, what is the ID of this step. Okay, then tool function. Here all tools, I defined a dictionary, right, where we will provide a string name, and then it will rather give me the function of that tool. Okay, simply we will use that function, we will invoke it, we will provide an input text, and we will get an output. Okay, the final result will be the step ID, what is the current step, the tool that I used, the input that went into that tool, and the output. Here I'm providing a sleep of 2 seconds just to demonstrate that how one by one each output is coming. But if you don't want this, we can remove this. And final output that will be returned is step results will be this dictionary. In step results field, we will simply add this dictionary. Since we have provided a reducer there, which is operator.add, so it will add this dictionary to step results list. Okay, and then current step index we will increment from 0 to 1. So as a first step it was 0, now it will be 1, and later it will come 2, and so on. Okay, this is the conditional node, conditional router node, where it will take state, and it will check whether the current step index that we have currently defined, whether it is greater than or equal to length of the steps. Okay, when it is greater than equal to, then it will become true, like you can see here. Otherwise, it will remain false. Okay, then finally is the synthesizer agent. Synthesizer agent, nothing. We are doing giving the uh, user input, user question. Then we are taking all the SEP results. This is a list of all the dictionaries. We are simply converting it into a string JSON. Okay, and we are simply asking it to answer this question from the user using the completed output. And this is the completed output. Okay, completed output is nothing but the output of each uh, tool saved in form of a list. Okay, then the final answer will be this pinout.content. If you see here we are using the raw LLM. We are not using structured output because we want a string free format text output from this node. Okay, now we will define our workflow. So we will start the state graph based on this state that has all the required fields. We define all these nodes. We have planner node, assign worker node, executor node, and synthesizer node. Then we start define the edges. So it will start from planner node. From planner node, it will go to assign workers. And from executor, these are the fixed edges. Okay, if you see here, from start, it is going to planner node. From planner node, it is going to assign workers. And from executor node, it is going to assign workers again. Okay, so these are all fixed. But from assign workers, we have a conditional edge. So from assign workers, we are using this conditional router is done. So is done will return true if all the length of steps is already reached the index level. Then in case of true, we will go to synthesizer agent. But if we have not executed all of them, then it will be false and it will go to executor node. Okay. And then from synthesizer, we simply connect it to the end node. Okay, so this we have defined. Now we will compile it, and optionally we can just save this graph in form of an image. So this is the saved image that I showed you. So this becomes very handy when we have to explain it to somebody or we have to understand what exactly it is doing. Okay, so remaining is just the Flask code where it is taking the user input. Here you can see it is taking the user input, it is giving to the uh, my flow and then generating this output. For this behavior, I took some help from ChatGPT to generate a JavaScript so that we can demonstrate. Let me try to run this again. So let's ask the same question and see how it is working. So now this time it generated only two steps, output of first step, output of second step, and this is the final output generated by the synthesizer agent. Okay, so this I have created in using Flask and JavaScript and HTML. But if you want to see this capability in Chainlit or Streamlit, please let me know in comments, and I will just use the same code, same backend code, and try to show the same capability in Chainlit or Streamlit if you want to see that. Okay, so this was from my side on planner based orchestration. So let me know in comments what other concepts you want to understand uh, specifically for LangGraph or AI, and I will try to create a video on that. So thank you so much. Uh, Bye.